Hey, good morning, afternoon, and this is section 6.6, multiplying binomials using special product rules, and I'm on page 361. This is the second part of 6.6, so let's just start. So I'm going to multiply this using the distributive property, FOIL method, or generic rectangle. I'm choosing just to distribute. And so that's my solution. The next question, I'll use the special product rule to make the multiplication process a lot quicker, okay? So, first question was done using, looks like the FOIL method, first outer, inner, last, combining like terms. And of course, that is the product of the square of a binomial, x squared plus 4x plus 4. So, same idea, the square of a binomial, but now I'll use the shortcut. So the shortcut says that you take the first term, which is 3, square it. So I'll write that down. 3 squared is 9. I'm not going to show my work, I'm just showing you the shortcut. That's why it's called a shortcut. And the rule is, if I were to write it out, it would be and so a is the first term, b is the second term in the binomial. So I squared 3, it's a squared. The middle term, I'm going to skip that, I'm just going to go to the last term first. Square that. And the middle term is the first and last term, the product, times 2, or double the product of the first term and last term. So double the product of the first term and last term. So 3 times a is 3a, times that by 2, and it's 6a. So I rewrite this in standard form. Now I always start off with the first term squared, the last term squared, and then with 2 terms, first and last, the product doubled. If you're comfortable, you can start with the first term squared, the first and last term, the product of that, and double that, and then square the last term, and you can produce an answer in standard form right away. But I chose to do it this way. Okay. Next question. Again, I'll work this one out using the FOIL method. Expand it. Why not use generic rectangles? Let's use generic rectangles. So multiply my product. 3a times 3a is 9a squared. 3a times 2 is 6a. 3a times 2 is 6a. And 2 times 2 is 4. Okay, we have our signs. All these are positive values, so when you combine them, you end up with 9a squared. That's our first answer. Combine the like terms gives us 12a. And adding the constant. Number 7, let's use the shortcut. Again, the shortcut is take the first term and the last term and square it. So the first term squared is b squared. The last term squared is 3 squared is 9. And then take the first and last term and multiply them and then double the product of the first and last term. So that would be minus 60. Again, it's negative since we're taking the difference of the terms. Okay. And so my solution is the shortcut. Moving on. Guess out the long way. Negative times a negative is positive 100. Moving on. Choose the shortcut. First term squared. Well, 4 squared is 16. N squared is n squared. The last term is 9. 9 squared is 81. And then the middle term is 9 times 4, the product of the two terms, and you double it. So first and last term, product doubled. So it's 36, and doubling 36 gives us, what is double 36? 72? Yeah, 72 and minus 72m. Okay, and so standard form. Great. Okay, this is the sum and difference product rule. And our middle terms cancel out. So let's do it the long way. You'll see the middle terms cancel. Positive 3x, negative 3x. And so our solution is, and again, minus 3x plus 3x, we lose our middle term. And so here's the shortcut. The shortcut, it's very nice. You just take the first term, square it. Take the last term and square it. It's the difference of the first and last term, and that's your answer. So x squared is x squared, and 6 squared is 36, and so it's x squared minus 36. Okay? It's also called the difference of two squares. And there's also can be written this way. You see that in the difference of two squares. Moving on. Nice. Again, it's the sum and difference product rule. So, shortcut. Take the first term and square it. It's be 10 times 10 is 100. X times x is x squared. The last term is 7y. 7 squared is 49. Y squared is y squared. So this is the solution. Again, the way that was arrived, it was that, right? You see that? You squared that number. You also squared 49, right? Or 7. So I'm just kind of showing you the background there, okay? That confuses you, sorry. This is not the answer, it's just background information. Alright, moving on. Last question. Number 19 says, write a simplified expression that represents the area of the large rectangle, the area of the small rectangle, and the area of the shaded region. So the large rectangle is the whole rectangle. This is the large rectangle, I'm highlighting it. It's the length, and that's the width. And so the area of the large is represented as length times width, which is going to equal, if this is the length, I call that L, call this the width. So it is the sum and difference pattern. And of course, FOILing gives you the proper answer, but I will go straight to the chase and give us this answer. It's going to be 36 minus x squared. Okay. All right, let's look at our small rectangle. Same idea. Use green as color. Keep things clear. So you've got length of the small rectangle. And area equals length times width. So that would be and so my sum and difference pattern, first term squared is 4. The last term squared is x squared, so it's minus x squared. And very nice. So what is the area of the shaded region? Well, it's the area, use black, the area of the shaded region, I'll call it AS, is equal to the area of the large region minus the area of the smaller region. And we'll just say SM for small. Okay? So we're subtracting two polynomials. That would be 36 minus x squared. And we're going to subtract. Got the subtraction sign. Isn't that good? Did you get that? We're going to subtract 4 minus x squared. Okay? Now, we might get an answer here, it looks like. I don't know if this is, let's just go with it. See what happens. So, distribute the negative sign. And we end up with we're going to get some reduction here. And the answer looks like it's going to be 32. Okay, so solution is 32 square units. Not sure what we're measuring by, but that seems to be the answer. So, hey, thanks again for listening and watching. I hope it was helpful. And like I always say, study hard and learn a lot. We'll see you later. Bye-bye.